We have a SwingGen here, which basically consists of a DC gear motor where we hooked up the shaft to a lever, basically, and this lever turns the gear motor in first forward and then backward direction, which produces AC out of it, which we rectify and run through the capacitor for a DC output. So what you'll see here is a voltage start up just after pushing this with one finger. This is a ballast weight here of probably 30 gallons of water, and I can get it swinging. There's like 11 volts, 10, 12. With next to no effort whatsoever. We're generating power to crank that fan over. You can hear it pulsing, but the surges of power that we can smooth out with capacitors. And yeah, I'll just push it with one finger. It's actually easier down here. You can push it with one finger to be cranked. What would normally take a lot of effort to crank by hand, we can do it with just one finger to get an enormous amount of power output. If we increase the scale of this to a small jacuzzi with a single person just splashing water back and forth, we can get the momentum of all that thousands of pounds of water now to put an enormous amount of force on this lever. As this thing swings, you'll see the flexing that goes on here, which if you were to stick your finger in there, that would be quite painful, because the amount of force that this water puts on that is enormous, but it takes next to little effort to keep the thing swinging. So one person is actually capable of over 40,000 watts of power using a 40-foot swing set. We can set up a water pump, either powering electrically using this method, or we go straight to a reciprocating plunger pump. As this thing cranks, it's going to be throwing the plunger back and forth to pull a large amount of water up for every single swing. So one person could actually produce equivalent of 40,000 watts of power just pumping water. Or we can actually set up a momentum system, whereas the water is pumped up, it's pumped into the ballast weight itself to sustain a wave bouncing without a person even doing it. Because it is so easy to swing such a large amount of weight and generate such a large amount of power, I believe we can actually set this up where we don't need a person involved at all. But if you want to follow me in here, you can see the larger model that we're proposing that we build for about $40,000. I believe we could build a 40 kilowatt pumping station, either going directly to a plunger system or with electromechanical, the way we are in there. With the strictly mechanical system, this plunger system would have a set of check valves, very inexpensive. We have to charge a lot more for electromechanical because those motors aren't cheap, but this, however, is much more cost-efficient design for just pumping water. And I believe we could actually use the water that's being pumped to pump it through the ballast weight that's swinging to sustain the momentum indefinitely until the well runs dry. So theoretically, we'd have a self-sustained system, providing there's always water for it to pump, and it could continue pumping itself just by maintaining its swinging momentum by sloshing a wave back and forth. So with a system like this, well, this is a half scale one at 15 foot, 12 foot tall, 16 foot beams actually. Takes up a pyramid design like this would take up 15 by 22, say 16 by 20 basically. It's a we'd actually plan on going about twice that size for a 40,000 watt system. but this is just a proposed half-scale model that we can start. For as little as $20,000, we can build you a 20K. We're back without the water in the way. I can show you just how much fun this is, which I believe will be a great exercise thing for people in the future, as well as a great way to sustain power for your home without doing much actual work. I'm just going to pull, just kind of holding for balance really, hardly putting any force whatsoever onto this. And you can see the voltage is actually well over 15 volts already. 15, 9, 14 volts, 12 volts. Anyway, it's a lot of fun. You can just pull on that, on this little handlebar, and keep yourself swinging with relative ease. In fact, the heavier you are, the more force you'll be putting on the lever, and still only do a small amount of work to just get yourself swinging and keep yourself swinging. So you can hear the fan. I don't know if you can see how much wind is blowing in my hair, but it's a really good breeze going when we're pushing 16 volts through a 12-volt fan. We'll hook up a water pump on this so you can actually see visually how much work we're actually doing. But you actually have to try this and see, just feel for yourself how little effort it is to swing on this thing. And with this effort right here alone though, you could be powering your television in your house without having to work your butt off on a bicycle. This is way, way easier than a bicycle power generator. So this is the way to go, is swinging, to put your whole body weight into it with next to very little effort. So anyway, hope you like what you see. We'll have bigger and better stuff soon. See you then. Bye.